initial studying mechanical waves which require a material medium for their propagation. The aesthetic influence of waves on art and literature is seen from very early times. At the scientific first scientific analysis of wave motion dates back to the 17th century. Some of the famous scientists associated with the physics of wave motion are Christian Huygens, Robert Hooke, and Isaac Newton. The understanding of physics of waves followed the physics of oscillations of masses prior to the springs and physics of the sample pendulum. Waves in elastic media are intimately connected with harmonic oscillations, a stress, a strength, quiet spring, air, etc. are examples of elastic media. Now, we have shown a picture, a combination of three springs, a collection of springs connected to each other to explain the behavior of propagation of waves. We consider a collection of springs connected to one another as shown in figure 1. If the spring at one end is pulled suddenly and released, the disturbance travels to the other end. What has happened? The first spring is disturbed from its equilibrium length. Since the second spring is connected to the first, it is stressed or compressed and so on. The disturbance moves from one end to the other, but each spring only shows small oscillations about its equilibrium position. As practical examples of this situation, consider a stationary train at a railway station. Different bogies of the train are coupled to each other through a spring coupling. When an engine is attached to one end, it gives a push to the bogie next to it. This push is transmitted from one bogie to another without the entire train being bodily displaced. Now, let us consider the propagation of sound wave in air. As the wave passes through air, it compresses or expands a small region of air. This causes a change in the density of that region. Say delta rho. This change induces a change in pressure delta P in that region. Pressure is force per unit area, so there is a storing force proportional to the disturbance, just like in a spring. In this case, the quantity similar to extension or compression of the spring is the change in density. If region is compressed, the molecules in that region are packed together and they tend to move out to the adjoining region, thereby increasing the density or creating compression in the adjoining region. Consequently, the air in the first region undergoes rarefaction. If a region is comparatively rarefied, the surrounding air will rush in making the rarefaction move to the adjoining region. Thus, the compression or rarefaction moves from one region to another, making the propagation of a disturbance possible in air. In solids, crystalline atoms or groups of atoms are arranged in a periodic lattice, displacing one atom, keeping the other fixed leads to restoring forces. Thus, we have studied the mechanical behavior of propagation of mechanical waves, and it is required a material medium or transmission from one point to another point.